Hi everyone, I'm Trang Nguyen. Today I'm going to talk about my final report for the subject 955 Research Engineering Research Methods. This is a thesis about pretension in capables. So, this research investigates how the application of pretension affects the shear strength of capables with relevance to their role in reinforcing underground mines. The strength characteristic of tendons serve as the fundamental basis for their safe utilization in various ground conditions. Pretension plays a constructive role in managing the conditions of both the roof and bedding plants, ultimately resulting in a more dependable and stable roof structure. Particularly, higher pretension results in a higher force of shear strength. According to Zhang, 2019, this is achieved through a more profound comprehension of the mechanism by which loads are transferred and the interactions between the bonding system and the diverse ground conditions. Higher pretension is also likely to lead to cable ground interface failure because it results in a greater vertical displacement difference between cable bones and surrounding rock mass. Now I will talk about my research design. The objective of this study was to investigate the influence of pretensions cable bones. So cable bones of various types, including plain and intent ones, along with plain 19 wide cables with a diameter of 21.7 millimeter, were subject to testing with predefined pretension levels from 0, 7.5, 10 to 15 tons. The modified double shear apparatus MK3 was employed to eliminate any friction between the surface of concrete block joints during the shearing process, with the aim of determining the shear strength of cable bones. So, shear tests were conducted on pretension fully ground cable bones. In the test, concrete blocks were placed in a manner that prevents any contact between them. The double shear assembly comprised 3 concrete blocks with the outer side cubes measuring 300 millimeter on each side, while the central rectangular block was 450 millimeter in length and have a cross section of 300 times 300 millimeter. Before assembling the cable for the double shear test, each cable with central grouting holes was completely filled with grout in advance. This grouting was done at least 1 week before the cables were installed in the double shear assembly. Following the pretensioning of the cable bond, cementitious grouts were introduced into the holes using vertical openings located on top of the concrete blocks. The tests were carried out several days after the pretensioning and encapsulation of the cable bonds. Finally, I will assess my research design. So by comparing these cables with different properties, a better comprehension of the pretension performance were attained. The advantage of this approach is that a new and larger double shear apparatus, assembly MK3, was then adapted for the purpose of examining the impact of pretension fully ground capables. In addition, this method used the functions of pretension in a manner that previous studies could not achieve. The drawback of this approach is that various methods need to be employed to prevent grout from leaking out of the blocks during the installation of the capables. Thank you for listening to my video.